The next type of transformation we're going to talk about is a rotation. So yesterday, or the last couple days, we talked about translations and reflections. And all we had to do those transformations was to count. Okay. Rotations are a little bit different. They're going to be a little bit more work, but they're not too bad. Okay. You can't get away with counting with rotations. Some things before we start diving in on how to do a rotation. A rotation is just the turning of a geometric figure about a fixed point. Okay, so translations are slides, reflections are flips, rotations are turns. So you're just turning a figure about a fixed point. The center of rotation is the fixed point about which the figure is turned. In this class, our center of rotation is always going to be the origin. Okay, so whenever we rotate a figure, we are always rotating that figure about the origin. Okay? Every time. The number of degrees the figure is turned is called the angle of rotation. Okay? And you can rotate a figure clockwise or counterclockwise. We primarily will rotate figures by 90 degrees, 180 degrees, and 270 degrees. Okay, those are the degrees that we're going to rotate figures by. Right? And we're always rotating around the origin. Majority of the time, we sometimes write a rotation like this. You might see it like this sometimes. Okay? There's a little r, which stands for rotation. It has the degree or angle of rotation. O stands for origin, because again, we're always going to be rotating about the origin. And then the figure you're rotating. So if you see it written like that, that's like saying, hey, take triangle ABC, rotate it 90 degrees about the origin. That's what that's saying. Normally, majority of the time, it's going to be written out in a sentence form. Something like, rotate figure 90 degrees counterclockwise. Okay? It will tell you the direction and the angle which you're rotating by. Okay? We're always rotating about the origin, so you might not necessarily always be told rotate this about the origin. Okay? Questions over that? So here below is a summary of the rotations for counterclockwise. We primarily, the main types of rotations in math are always going to be counterclockwise. We can rotate clockwise. We'll talk about that at the end. But we're primarily rotating counterclockwise. Those are our normal rotations. Okay? And counterclockwise is just the opposite way a clock turns. So counterclockwise is this direction. Okay? So you're kind of turning towards the left. Okay? That's counterclockwise. So first, to do a 90-degree rotation, again, we have a little r that says to rotate 90 degrees about the origin. We're rotating this point. If you notice the rule, x and y, they traded places, and then we changed the sign of the y. Okay? How I like to think of this, and you'll hear me say this a lot, when you do a 90-degree rotation, you're going to flip, then change the sign of the first. Flip and change the first sign. That's what you do when you do a 90-degree rotation every single time. It's counterclockwise. Okay? So if we take a look at here, this example, we have this point, 2, 3. Using that rule, flip and change the first. I always flip my point first. So when we flip 2, 3, it's going to become what? 3, 2. Always flip first, and then change the sign. Change the sign of the first, so we're going to change the 3 to a what? Negative. So now our answer is negative 3 over 2. There's where it's plotted on your graph. You notice how many quadrants did that figure jump? 1. Yeah, and remember the quadrants, think back to your pre-algebra days, that's quadrant 1. And we go counterclockwise with our quadrants as well. That's quadrant 2, quadrant 3, this guy's quadrant 4. That's poorly drawn. it jumped 1 quadrant. And then for every extra 90 degrees you rotate, that's how many quadrants it's going to jump. So we only rotated it 90 degrees, so it jumped 1 quadrant. The next type of rotation we're going to talk about is 180 degree rotation. You notice the rule here. Did the X and the Y trade places? No, but what happened to the signs of both of those numbers? They changed, right? So that's the rule for 180 degrees. There's no flip, but then you change the sign of both. Both numbers, you change the sign. So 180, there's absolutely no flip. You just change the sign of both. So we look at this example, we have the point 2, 3. Okay? We're rotating at 180 degrees. So the 2 and 3 stay exactly where they're at, but they're both going to turn what? Negative. They stay exactly where they're at, but they change the opposite sign. So they're both going to turn negative. So then you would plot -2, -3, and there it is. Okay. How many quadrants did it jump when we did 180 degree rotation? 2, because think about it. 90 would land us here. Another 90 would be here. So 90 plus 90 is 180. So we jumped 2 quadrants. And then the last one we're going to talk about is a 270 degree rotation. And with the 270, did the X and Y trade places? Yeah, but which sign did we change this time? The second. So when you do a 270 degree rotation, you flip, but this time you change the sign of the second. So how this looks like, again, we have this point 2, 3. We flip to make it become 3, 2, and change the sign of the second. So we go to our new second number, and that positive 2 is going to become what? Negative. So we plot 3, -2. There we go. How many quadrants did this guy jump? Counterclockwise. It went how many? 1, 2, 3. Because again, 90 plus another 90 plus another 90, 270. And that wasn't very well curved. Ah! What am I doing? Go back. Pen kind of caught there. But it jumped 90 degrees. Or 200. Okay? And then 360 is a full circle, so where you start, that's where you're ending, so nothing changes. Okay, we don't really talk about 360 degree rotations regarding transformations. Okay? Questions over that. One helpful way for me to remember these is when I'm counting, think 90 and 270, the first type and the last type of transformation rotation that you flip. So 90 and 270, you're flipping. Okay? To remember which sign you're changing, whether or not it's the first or the second, when you're counting, 90 comes first. So you change the sign of the first. Okay? 270 starts with a 2. 270 has a 2 in it. So you change the sign of the second. Okay? And then 180, there's just you don't flip anything, you just change the sign of both. Okay? Questions over that? Let's look at some examples. We take a look at this example on the back. We're going to graph the image of the following figures using the given transformation. Again, when you see those directions, all you're doing is you're taking the given figure, doing the transformation, and graphing it. The image is your answer. Okay. So, with translations and reflections, you could get away with not having to really write anything down. You just count it. Rotations, you have to write things down. You have to do work with rotations. Okay? So we take a look at A. It says rotate 180 degrees counterclockwise. Whenever you see counterclockwise, that is the normal way you rotate something. So I'm going to write down all the vertices of this figure. So S is at -5, -2. P is at -4, -4. Q is at -3, -4. And R is at -5, -2, -4. Q is at -4, -4. P is at -3, -4. Q is at -5, -2, -4. Q is at -3, -4. Q is at -4, -4. Q is at -5, -2, -4. Q is at -3, -4. Q is at -5, -2, 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 -4. is at -3, -3. Okay? You write down all the original points. And then you do the transformation to those points. So we want to rotate 180 degrees. So we rotate 180 degrees. Do we flip the point at all? Are these points going to flip? No. What happens to the sign of both numbers though? They change. So this is a -5 and a -2. It's going to become what? +5, +2. We have a -4 and a -4. They're both going to become what? Positive. We have a -3 and a -4. They're both going to become positive. We have a -3 and a -3. They're both going to become positive. Sometimes your points are different. One of them, the first number might be positive and the second one might be negative, and you're doing a 180-degree rotation. That's fine. You just change the signs to the opposite of whatever they are. Same rule still applies. And then once you do that, you just plot your new points. 5, 2, x prime, 4, 4, 3, 4, there's p prime, q prime, and then r prime. Stop. And then we rotated 180 degrees. We know it's supposed to jump 2 quadrants, and it's in the 2 quadrant jump. So we're good. Questions over that? The next one's asking us to rotate 90 degrees counterclockwise. And when you see counterclockwise, that is a normal rotation. So go ahead, write down the vertices of the pre-image, the original figure. I'm going to write A prime, P prime, C prime, and D. So with a 90-degree rotation, what happens to the point? Do the X and Y stay where they're at, or do they switch? With a 90 degree. What do we say the rule was with a 90-degree rotation? You flip, so we're going to flip all the points. Worry about the sign until after you flip. Change the sign of the first. You go through, change all your new firsts. They're all happen to be positive, so they're all going to change to a negative. That doesn't always happen. Sometimes some of them are positive, some of them are negative. Go through and change them to the opposite. And then plot your new points. So plot -1, -4, -1, -2, -3, -2, and then -4, -5. Okay. Questions over that? This next one, rotate 270 degrees counterclockwise. So again, I'm going to write down all the original points. And it's really helpful if you label too. That way you know which point belongs to which vertex. Not labeling like get yourself confused. Okay? Oh, why did I write times for those? Each one of times. Sorry. Okay, 2 steps ahead. So then we have A prime, B prime, C prime. Okay. With a 270-degree rotation, what do we do with the point? Okay. Flip the point. 270 to 90, you always flip. change the second. Again, think 270 has a 2. So we change the sign of the second. They all happen to be negative. So we're going to change them all to positive. And then plot your new points. 2, 5. Move A prime. 1, 2. Move B prime. And 3, 3 is C prime. And there we go. Turned it 370 degrees about the origin. Questions over there? Not too bad, you just have to write down your points and remember those rules. That's a hard part, remembering the rules. Making sure you have them straight. So might just take some time to sit down and try to memorize them. Just tell yourself 90 degrees, flip and change the first. 180, no flip, change both. 270, flip, change the second. Okay. So now we're going to talk about how to rotate something clockwise. This isn't, the main thing I want you to remember is how to do counterclockwise rotations. Those are the main type of rotations we want you to know. I just want you to be familiar with clockwise rotations. And so if you're asked to do a clockwise rotation, you're familiar with how to do it. But don't be overwhelmed by clockwise. It's not too bad. Okay. If we take a look at A, it's asking us now to rotate 90 degrees clockwise. Okay, so whenever you see clockwise, that's not the normal way you would rotate. So we're not flipping the point and changing the first here, we're doing something a little different. Because clockwise is going the direction of the clock. And when we rotate something 90 degrees, how many quadrants does it jump? When we rotate something 90, how many? 1. Okay? And we're going like a clock, so we're going towards the right. Nope. That's not the way. Clocks go this way, sorry. We're going towards the right. Okay? So we're jumping this way 1 quadrant. So we want our figure to land somewhere in here. Okay? We want it to land in that quadrant. Okay. So, we only know counterclockwise rotation. So think, what counterclockwise rotation do I know that will also land me in that quadrant? Yeah, 270, because we rotate something 270, you're going counterclockwise, you're still jumping 1, 2, 3 rotations. So we'll still end in that quadrant by doing a 270 degree counterclockwise rotation. So think, when you have a 90 degrees clockwise, it's opposite. It's going to be 270 counter. Yes?
How's that 90 degrees clockwise?
Sorry, I get those confused. You know what I mean. We're going the opposite way. My brain gets those mixed up sometimes. It happens. I just wrote it wrong there. This is where we want to go. So if we go 270, we land there. Sorry. So, a 90 degree clockwise is the same as 270 counter. When you're asked to do a 90 degree clockwise, then it's opposite. You're actually doing 270 counter. Okay, because, sorry, I get it mixed up. It's one of those things I really like. Some people like your left and your right, and I really have to think about my left and right still. Clockwise and counterclockwise, I really have to think about it. It's how your brains are wired. Okay. So, go ahead, we're going to write down all these points. And then we're going to do a 270 counterclockwise. So we do 270 counterclockwise again. What do we do with that point? What happens with the point? Let it change the second. So I like to flip my point first. And then go through and change the sign of the second. And then reflect them. And connect. So there we go. S prime, R prime, Q prime, and P prime. So if we look at 180 clockwise rotation, when we do 180 degree counterclockwise rotation, how many quadrants do we jump? 2. Okay? So clockwise, again, we're going to go the direction that a clock goes, which is this way. 1, 2. So we want to land in this quadrant when we do a 180 clockwise. Well, what counterclockwise rotation will get us to that same quadrant? It's the same thing. Yeah, 180 doesn't change. 180 is the same clockwise. 180 is the same counterclockwise. So you would write down all 4 points. Okay? And then with a 180 degree rotation, what is the rule for 180 degree rotation? We flip the point at all? With 180? We live today? Super quiet today. What's the rule for 180 degree rotation?
Stays the same.
Yes, thank you. No flip. You just change the sign of both. So I'm leaving it for you to do that to do on your own. So with a 270 degree clockwise rotation, how many quadrants are we jumping when we do a 270 degree rotation? How many? 3. So again, we're going clockwise, the same direction as the clock. So 1, 2, 3. We want to land in this quadrant. Well, what counterclockwise rotation will land us in that quadrant? A 90 degree. Okay. Again, I'll leave for you to do that on your own. Okay. So think whenever you're told to do clockwise, 180 stays the same, but 90 and 270 switch. So if this is 90 clockwise, that's actually 270 counterclockwise. 270 clockwise is actually 90 counter. 180 stays the same though. Okay. Questions over that? Okay. The rest of the time is yours.